All right, 16.3, using trigonometry to solve a right triangle in the unit circle. So, basically, we can always use trigonometry to solve when we're given an angle and a side, or two sides to find an angle, which is what we learned about in 16.1. But for example, say I wanted to set this up. I know that cosine of 45 is equal to 1 over radical 2, which we know rationalizes to radical 2 over 2. Okay, and I could do this with all of them. I could do it with sine as well, and it would be 1 over radical 2 again, which would be radical 2 over 2, right? And then I could do it with tangent of 45. Tan is what over what? Oh, you don't have to write this part. It's just like a...
How do you go from 1 over 2?
You can if you want to write it. It's not that big of a deal. What'd you say?
How do you get 1 over 2 to 2 over 2?
Oh, that's just rationalization. So this part's just like me recapping how we know that these exact values. That's all. Radical in the denominator. We already have addressed. This is not that important. Okay. Yeah. Okay. So the main takeaway right now is the fact that we can come up with sine and cosine given a triangle by using those rules. So we know that this right here represents the radius of the unit circle, right? And we know that this is the vertical and this is the horizontal. So sine would be opposite, which is y, over r, right? Because opposite over hypotenuse. We know that cosine is x over r, because it's adjacent over hypotenuse. And what would tan be? Y over x. So these general rules will always get you a value on the unit circle, okay? Now, with that, what you're going to notice is, if we're talking about the unit circle here, what do we know that r is always? The radius is always 1 of the unit circle. So isn't sine just equal to y? And isn't cosine just equal to x? Yeah, it will be 1 over, or it would be x over 1, right? So then tan would just be y over x. Now, I'll explain why. We know that tan of theta is actually just sine over cosine, okay? Sine over cosine. And the reason for that is, I'm going to prove to you why it works. Sine is y over r, and cosine is x over r. So when I have a fraction divided by a fraction, it becomes keep, change, what? Flip. What's going to happen with those r's?
Cancel.
Which leaves me with what?
Y over x.
See how that's y tangent is y over x? Because tan is equal to sine over cosine. So if there's one important thing you take away from this for it, the lesson is that sine over cosine is equal to tan, and that when we're looking at ordered pairs on the unit circle, xy is equal to cosine comma sine. So cosine is x, sine is y. That's the main takeaway here. This bit in the boxes is the most important thing you need to know for the homework. Okay? All right. That's,
Can you go back real quick?
yeah. So as for the next slide, this one is just kind of reiterating that idea that this is our x distance, our y distance, that's where these coordinates come from, okay? Same idea is it's really just cosine, because we know that cosine is adjacent over 1, anything over 1 is itself, and this is just sine, because sine is opposite over hypotenuse, which is just itself over 1, and that's the reason that x is cosine and sine is y. And then this is just showing you how Pythagorean theorem also translates to what we would call a trigonometric identity, which is basically me just replacing cosine with x and sine with y. So now what I'm going to do is I'm going to do a few of your homework problems with you guys. So does everybody have the homework? Whoa. All right. I'm going to do the first few problems with you guys. I'm going to do the first 4 with you guys, okay? So first one says sine of 45. Now, when you're doing this homework, It's a lot easier to have your unit circle out. So do you guys want to take a second to get out your pink unit circle sheets? All right, so at this point, guys, we're still doing stuff, so can you guys focus? You're going to make the video way longer for the other people. Okay, so if you look at your unit circle when it says sine of 45, now I know that you could put this in the calculator, but the problem is the calculator is going to give you a decimal. We don't want that. We want what we call an exact value. So sine of 45, you're going to look at the angle and make sure it's positive. If it's positive, you're going to just look at the unit circle and find where 45 degrees is. Does everybody see where 45 degrees is? Now, we look at the coordinates at 45. Sine is going to be the y coordinate. So what is the y coordinate at 45? Radical 2 over 2. That's the answer to your question. Okay, so these problems are not difficult. The next one we're going to look at is cosine of negative, 45 degrees. So when your angle measure is negative, you're going to add what to it? 360 to find a coterminal angle. So I took it and I added 360 to it to get a coterminal angle. Okay. Then I'm going to look at where 315 is on my unit circle. So find the 315. Now if sine is the y, what do you think cosine is?
X.
So what is the x coordinate at 315?
Negative radical 2 over 2.
Negative radical 2. Is it negative? I think it's positive. Okay, I was going to say. Okay.
Can you just do like 360 minus 45?
That's what we did to get 315. Yeah. Same thing. Okay. So the next one is tan of 60. Okay. So whenever you encounter a tangent problem on one of these, you're going to change it into sine of the angle measure over cosine of that angle measure. It's always sine over cosine. And now we're going to go to our unit circle and find what sine of 60 is and what cosine of 60 is. So what is sine of 60 degrees? Good. And what is cosine of 60? 1/2. If I want to divide fractions, I'm going to keep, change, flip. What's going to happen with those 2's? Which becomes radical 3 over 1, which is just radical 3. So that's the answer to the question. Would you guys like to do one more?
Yes.
Okay. Let's do tan of 30. So when it's tan, how are we going to rewrite it? Good. Sine of 30 over cosine of 30. What is sine of 30? Good. What is cosine of 30? Radical 3 over 2. This becomes 1/2 times 2 over radical 3. What's going to happen with the 2's? Which leaves me with, but we can't keep a radical in the denominator, so we got to multiply top and bottom by radical 3. That's called rationalization. Yeah, you get radical 3 over 3 as your answer. Now, how you can check your work on the test, everything, you can't do it in the calculator, but you can check your work. If you put radical 3 divided by 3 in the calculator, you're going to get some decimal, right? You would get the same decimal if you did tan of 30 degrees in the calculator. That would verify that you did the math correctly.
Can you just like do tan times 30 and then whatever the number you get, put over 100 and divide by there?
It's not like that because it's in radical form, so you can't undo a radical form in the calculator. Yeah. Make sense? Okay. So that's what you guys